So students, in the previous video we were discussing about chain rules. Actually I have discussed 3 or 4 chain rules, and in this class also I will be discussing the continuation of chain rules. I have 2 more chain rules to be discussed in this class, and these rules will be the last among the chain rules that I will be discussing. So in the previous class W was a function of xy, xy was a function of t. That was our first chain rule. The second one was W was a function of xy and xy was xyz. W was a function of xyz, f of xyz, and xyz were functions of a single variable t. The next chain rule stated that W was a function of xy and or W was a function of u and v, and u and v itself were functions of 2 variables x and y. So in the first case we were able to find total derivative. In the second case, or the case where W is a function of uv and uv are functions of x and y, we found out the partial derivative dou w by dou x and dou w by dou y, and we have extended the definition to the case where W is a function of u and v, and u and v are functions of 3 variables x, y, z. Now our next chain rule is something like this: W equal to f of x, y, z. The given function W has 3 independent variables x, y, z, and each of these variables depends on 2 other variables r and s. So W depends on x, y, z, and x, y, z in turn depends on r and s. So basically or internally W is constructed using 2 variables r and s. There are 3 intermediary variables x, y, and z. And these x, y, z are all in terms of 2 variables r and z. You just understand this diagram. W depends on x, y, and z. X, y, and z, each of which depends on r and s. So there are 2 variables r and s in W. Basically or internally there are 2 variables r and s in W. So we have to find the partial derivative. That is dou w by dou r and dou w by dou s. Partial derivative of W with respect to r and partial derivative of W with respect to s. And this is our first chain rule, that is dou w by dou r equal to dou w by dou x into dou x by dou r, dou w by dou x into dou x by dou r, plus dou w by dou y into dou y by dou r, plus dou w by dou z into dou z by dou r. That is the expression for dou w by dou r. The next one is partial derivative of W with respect to s, that is dou w by dou s. Dou w by dou s equal to, in the similar fashion, dou w by dou x into dou x by dou s, plus dou w by dou y into dou y by dou s, plus dou w by dou z into dou z by dou s. So this is one chain rule. The second chain rule is W is basically a function of 3 variables p, q, and r. W equal to f of p, q, r, and p, q, and r are functions of x, y, and z. 3 variables x, y. So there are 3 variables in the middle, and these 3 variables are again functions of another 3 variables in the end, in the bottom, that is x, y, z. W depends on p, q, and r. P, q, and r in turn depends on x, y, and z. So basically W is a function of 3 variables x, y, and z. So we have to find dou w by dou x, dou w by dou y, and dou w by dou z. This is our next formula. Dou w by dou x equal to dou w by dou p into dou p by dou x, plus dou w by dou q into dou q by dou x, plus dou w by dou r into dou r by dou x. That is the expression for dou w by dou x. Similarly, dou w by dou y. Look at the diagram. W is there, intermediary p, q, r, functions p, q, and r are present, and at the end there are x, y, z. So dou w by dou y equal to dou w by dou p into dou p by dou y, plus dou w by dou q into dou q by dou y, plus dou w by dou r into dou r by dou y. Now one more variable is there, that is z. Dou w by dou z equal to dou w by dou p into dou p by dou z, plus dou w by dou q into dou q by dou z, plus dou w by dou r into dou r by dou z. So these are the 2 chain rules that we are discussing in this class. I will be doing one problem using the first chain rule And the second problem using the second chain rule. This is a lengthy problem. One small topic will be given as assignment. Other two topics, other two quantities, dou w by dou x and dou w by dou y, we found out here. Now come to this problem. You are given w equal to x plus 2y plus z square, where x equal to r by s, y equal to r square plus log s, natural logarithm of s, and z equal to 2r. Find dou w by dou r and dou w by dou s. Now look at the ray diagram. Here w is a function of x, y and z. W has x, y and z as its primary variables. But x depends on r and s, y depends on r and s, and z also depends on r and s. So w is a function of x, y and z. X, y, z are basically functions of r and s. So this w becomes a function of r and s. W becomes a function of r and s. So we have to find the partial derivative. Basically w contains two variables, variable r and variable s. So we should have two derivatives, two partial derivatives similar to the first one, dou w by dou r and dou w by dou s. Now first we will find dou w by dou r. Dou w by dou r equal to, remember w is a function of x, y, z, and all our functions, all these variables are functions of r and s. So dou w by dou r means dou w by dou x into dou x by dou r plus dou w by dou y into dou y by dou r plus dou w by dou z into dou z by dou r. That is expression for dou w by dou r. Now dou w by dou r equal to dou w by dou x. Dou w by dou x is 1. X plus 2y plus z square. Dou w by dou x is 1 into dou x by dou r. Dou x by dou r. Dou x by dou r is 1 by s. X equal to r by s. So this differential of this quantity is simply 1 by s. Differential with respect to r is 1 by s. So 1 into 1 by s plus dou w by dou y. Dou w by dou y is 2. Dou w by dou y is 2. 2 into dou y by dou r. Dou y by dou r. Dou y by dou r is simply 2r. So 2 into 2r plus dou w by dou z. Dou w by dou z is 2z. This is our w. So dou w by dou z equal to 2z, and into dou z by dou r. Dou z by dou r is 2, simply 2. So 1 into 1 by s into 2 into 2r plus 2z into 2, that is 1 by s plus 4r plus 4z, or we get 1 by s plus 4r plus 8r, 4r plus 8r. That means I am substituting z equal to 2r. Z equal to 2r. So 1 by s plus 4r plus 4 into z. Z is 2r. So 4 into 2r, that is 8r. So 1 by s plus 4r plus 8r, that is 12r plus 1 by s. That is our dou w by dou r. So I am substituting z equal to 2r in this expression. That's all. So in order to get the whole dou w by dou r in terms of r and s, because r and s are the internal basic preliminary variables or the base variables. W depends on r and s. So I have expressed dou w by dou r in terms of r and s. Now come to dou w by dou s. Dou w by dou s equal to dou w by dou x into dou x by dou s plus dou w by dou y into dou y by dou s plus dou w by dou z into dou z by dou s. X, y, z are intermediary variables and r and s are the basic elementary variables. So dou w by dou x is again 1. Dou w by dou x is 1. Dou x by dou s. Dou x by dou s. R is a constant. So I have to differentiate 1 by s alone. Dou x by dou s. Differential of 1 by s is minus 1 by s square, and r is a constant. So I get r into minus 1 by s square, that is minus r by s square. Dou w by dou x is 1. Dou x by dou s. Dou x by dou s. Differential of this is minus r by s square plus dou w by dou y. Dou w by dou y is, this is my w. Dou w by dou y. Dou w by dou y is 2 into dou y by dou s. Dou w by dou y into dou y by dou s. Dou y by dou s means differential of this with respect to s, that is 1 by s. So dou w by dou y is 2 and dou w by dou s is 1 by s. So 1 into minus r by s square plus 2 into 1 by s plus dou w by dou z. Dou w by dou z is 2z. 2z into dou z by dou s. Dou z by dou s. There are no terms involving s in z. So dou z by dou s is 0. So this whole term becomes 0 and you get minus r by s square plus 2 by s, or taking the LCM, you get multiplying dividing by s in this expression, you get 2s minus r divided by s square. So w was a function of x, y and z. X, y, z were functions of r and s. So basically w becomes a function of two variables r and s. So I have found out dou w by dou r, partial derivative of w with respect to r. I have found out dou w by dou s, that is the partial derivative of w with respect to s, and I have expressed both of them in terms of r and s. So that was our first problem, and using the first chain rule written here. Now I am doing another problem. This is a lengthy problem. I am using this one because this becomes lengthy because I have three variables in the intermediary stage and three variables at the preliminary stage, at basic stage. So I will be doing two subsections. The rest one is left as a homework. Now w equal to p minus q by q minus r. W equal to p minus q divided by q minus r, where p equal to x plus y plus z, q equal to x minus y plus z, and r equal to x plus y minus z. Find dou w by dou x and dou w by dou y. So w basically, or w is, we see w as a function of p, q and r. But p, q and r are what? They are functions of three variables, other three variables x, y and z. So this will be our diagram. W depends on p, q and r. P, q, r each depends on the three variables x, y and z. So we have to apply the second rule. So basically w is a function of three variables x, y and z. So we have to find out dou w by dou x, dou w by dou y and dou w by dou z. So when we see, look at w, we will see only p, q and r, but all those p, q and r depends on x, y and z. So w comes in the form of a function of three variables. So we have to find three partial derivatives. The first one is dou w by dou x. Now generalizing this concept, this one is generalized to this. Now dou w by dou x, I am differentiating w with respect to x. So p, q and r are the intermediary variables. So dou w by dou x is dou w by dou p into dou p by dou x plus dou w by dou q into dou q by dou x plus dou w by dou r into dou r by dou x. Dou w by dou p into dou p by dou x plus dou w by dou q into dou q by dou x plus dou w by dou r into dou r by dou x. That is dou w by dou p, dou w differentiating this quantity, dou w by dou p with respect to p, you get 1 by q minus r. P, here p, the differential of p is 1, the differential of minus q is 0. So this is a constant. So 1 by q minus r into dou p by dou x. P is this one, x plus y plus z. So dou p by dou x is 1. So 1 by q minus dou w by dou p is 1 by q minus r into 1 plus dou w by dou q into dou q by dou x. Dou q by dou x is simply 1. Dou q by dou x. This is our q. So dou q by dou x is 1. So what is dou w by dou q? I have to differentiate this with respect to q. So p and r both are constants. So I am using f dash g minus g dash f. This result, f dash g minus g dash f divided by g square. D by dx, or the dou by dou x of f by g, that is f dash g. F dash means here I am differentiating partially with respect to q. So f dash, that is here f is p minus q, here f equal to p minus q and g equal to q minus r. F equal to p minus q and g equal to q minus r, and f dash denotes the differential of f partially with respect to q. Since I am finding dou w by dou q, so f dash means dou w by dou f by dou q. Differentiating this quantity partially with respect to q, you get minus 1. So f dash, that is minus 1. F dash g is q minus r, minus 1 into q minus r minus g dash f. G dash, g is this one. G dash means differentiating this expression with respect to q, partially with respect to q, you get 1. So g dash f 1 into g dash f 1 into 1 minus g dash f 1 into p minus q minus q minus 1 into q minus r minus g dash is 1, g dash is 1, g dash f means it is p minus q. So minus 1 into q minus r minus p minus q divided by g square, that is q minus r whole square. So that is our dou w by dou q. You have to differentiate this partially with respect to q. I am applying f dash g minus g dash f by g square, where f dash means dou f by dou q. Differentiating partially with respect to q, g dash is again differentiating g partially with respect to q, and I get minus 1 into q minus r minus p minus q divided by q minus r whole square into this 1. 1 is dou q by dou x. Dou q by dou x is 1 into 1 plus the next term is dou w by dou r. Here there will be one more minus 1 into minus 1, that is minus of p minus q by q minus r minus of 1 by x minus 1 by x square. So dou w by dou r means minus of p minus q by q minus r whole square into minus 1 into minus 1. The differential of minus r is minus 1. Differential of minus r is minus 1. So you get, here it is, on simplifying you get this p minus q, p minus q. Simplifying this, you get now dou r by dou x is 1, so this is p minus q, p minus q, that is you get 1 by q minus r plus r minus p. You here what happens is minus q and plus q get cancelled, so this becomes r minus p by q minus r whole square, and this becomes minus becomes plus, that is p, again it is simply p minus q. So you get, taking LCM, you get q minus r plus r minus p plus p minus q plus p minus q plus p minus q. That is what you are getting. So when we take LCM, the LCM is q minus r whole square, so I have to multiply and divide by q minus r. So the numerator becomes q minus r, so q minus r plus r minus p plus p minus q divided by q minus r whole square. Q get cancelled, r get cancelled, p minus p get cancelled, the answer will be 0. So there was a small doubt in this. The thing is that I am differentiating w with respect to r, dou w by dou r. So p minus q is a constant. The only variable part is q minus r. So you know that differential of 1 by x is minus 1 by x square, and here it is 1 by q minus r. So minus 1 by q minus r whole square into differential of minus r, that is minus 1. 1 by x, the differential of 1 by x is minus 1 by x square. So the differential of this quantity will be minus q minus r whole square, because r is a variable, p, q are all constant. So minus 1 divided by q minus r whole square into p minus q into differential of minus r, that is minus 1. So you get minus p minus q into minus 1 into dou r by dou x, that is 1. So you get simply p minus q, and simplifying you get dou w by dou x equal to 0. Dou w by dou x as 0. In the same fashion, I can calculate dou w by dou y. Dou w by dou y, the formula is dou w by dou p. Dou w by dou p into dou p by dou y plus dou w by dou q into dou q by dou y plus dou w by dou r into dou r by dou y. Dou w by dou p into dou p by dou y plus dou w by dou q into dou q by dou y plus dou w by dou r into dou r by dou y. Taking all the intermediary variables and the final variable. Now, dou w by dou p is 1 by q minus r, we have found out here. 1 by q minus r. Dou p by dou y. Dou p by dou y is 1. Dou p by dou y is 1. Now, 1. Dou w by dou q. Dou w by dou q, in the similar fashion, you get the same answer. What we have got here. Dou w by dou q. The same thing that you are getting, and not repeating the explanation. So this is my dou W by dou Q. Now dou W by dou R. Dou W by dou R is again here minus P minus Q by Q minus R whole square into minus 1 minus of P minus Q by Q minus R whole square into minus 1 into dou R by dou Y. Dou R by dou Y is 1. So 1 by Q minus R plus R minus P by simplifying this. When you simplify this, you get R minus P by Q minus R whole square into minus 1 plus P minus Q by Q minus R whole square. Again taking the LCM and simplifying, LCM is Q minus R whole square, simplifying you get the expression as 2 into P minus R divided by Q minus R whole square. So dou W by dou Y is 2 into P minus R divided by Q minus R whole square. But the problem is dou W by dou Y is now in the terms of P and P, Q and R. Actually, we are finding dou W by dou Y. It should be in terms of X and Y. Because X and Y, X, Y, Z are the primary variables. So I am substituting the values of P, Q and R. Substituting for P, Q and R or from this expression in dou W by dou Y. You get dou W by dou Y equal to 2 into, what is P? P is X plus Y plus Z minus R. Minus R means minus R is minus X minus Y plus Z. And this one also, Q minus R. Q is X minus Y plus Z and minus R is minus X minus Y plus Z whole square. And on simplification, you get this X, Y get cancelled. Z plus Z is 2Z into 2, that is 4Z. 4Z divided by, on simplifying this, you get 4 into Z minus Y whole square. 4 get cancelled and this is dou W by dou Y equal to Z by Z minus Y whole square. So you have got dou W by dou X is 0 and dou W by dou Y as Z by Z minus Y whole square. Now one more variable, one more partial derivative is there, that is dou W by dou Z. Because W is a function of X, Y and Z, we have found out dou W by dou X and dou W by dou Y. One more variable is there, that is dou W by dou Z. You do this as a self-study or homework and you should get dou W. The same method can be followed. Dou W by dou Z as minus Y by Z minus Y whole square. So this is all about that particular problem. In the first problem, W was a function of X, Y and Z and X, Y and Z was functions of R and S, only 2 variables. But in this case, W was a function of 3 variables P, Q and R, and P, Q and R were functions of 3 variables X, Y, Z. So in this case, there were only 2 partial derivatives, dou W by dou R and dou W by dou S. In this case, there are 3 partial derivatives, dou W by dou X, dou W by dou Y and dou W by dou Z. So these are the answers. Now in the coming classes, probably I'll be doing 2 or 3 extra problems so that you are some more thorough regarding, or you will be prepared, or it will be easy for you if I do, I think, 2 or 3 problems. In the coming classes I shall try to do it regarding the chain rule and some arbitrary problems. I'll be doing some sort of mixed type of problems in the coming classes. So I am stopping here for now. See you in the next class.